Magnification. Magnification means the ratio of size of the image to the size of the object is called magnification. Means here whenever the light is, some of the object is placed at a certain distance from the lens and the light is incident on the lens, then some of the image is formed, either diminished image is larger image, means the more height of the image or size of the image is more, maybe than the object or less than the object. So here it is that the ratio of the size of the image to the size of the object is called magnification, that denotes with m. Then its value depends on the position of the object placed. Means in front of the lens, on what position the object is placed, it depends on that the magnification. So here that is m is equal to size of the image by size of the object. There is two type of magnifications is there. Whenever the object is placed perpendicular to the principal axis, means like this. This is the lens and the object is placed at a distance of u, and this is the h be the height of the object. Then here the object O be the object is placed in front of the certain distance at distance of u. Then this will be is perpendicular to the principal axis, means whenever the principal axis is there, the object is placed like this, means perpendicular to the principal axis. Then the image is also formed perpendicularly, means whenever the image is formed also perpendicularly like this. So here it is that is called lateral magnification. That is lateral magnification. Here is that whenever the object is placed perpendicular to principal axis, image will be perpendicular to the principal axis. Lateral magnification, that means to say lateral magnification, it depends on the height of the image. So that's why the lateral magnification means the ratio of the height of the image to the height of the object. Here the height of the image I by height of the object, that is height of the object is h and height of the image is considered as h dash. So that is m is equal to h dash by h, means the height m is equal to h dash by h be the magnification according to the when the object is placed perpendicularly to the on the principal axis, the image is also formed perpendicularly. In terms of that is m is equal to h dash by h is in terms of, means the height of the image by height of the object in terms of u, v and f. That means to say the distance of the object and the distance of the image and according to the focal length. Then in terms of u, v, f, the m is equal to magnification is equal to image by object, that is equal to v by u, that is equal to f by u minus f be the equation. There m should be taken positive for the converging lens, means convex lens. Here the m put m is positive for erect image. Erect image means whenever the image is formed above the principal axis according to the sign convention. If in case of the any value can be taken above the principal axis, means height can be considered as it's a positive, and below the principal axis can be considered as a negative. Like this, here if the image is a inverted image, if the image is inverted image is formed, then that should value m value should be taken as a negative, and if in case of the positive, whenever the image is formed erect image, means above the principal axis. So like this, put m is positive for erect image and m is negative for inverted image. Inverted image means below the principal axis and erect image means above the principal axis. So that is the one type of magnification, that is lateral magnification. Lateral magnification means the ratio of the height of the image to the height of the object is called magnification. In case of in terms of UVF, then m is equal to v by u is equal to f by u minus f be the relation for magnification in terms of UVF. Then next, the longitudinal magnification means linear magnification. When the object is placed parallel to the principal axis, means here this is called a lens, this is the principal axis, and object which is having the length delta u, considering delta u be the length of the object, is placed in front of the lens. Then the image is also formed in the parallel to the image is also formed parallel to the parallel to the principal axis. So that's why for short linear object means which is having the short linear object lengthwise is very small, then the considering delta u be the length of the object and delta v be the length of the image, then that is a linear magnification ml is equal to the ratio of the length of the image by to the length of the object. That is by the calculation in terms of UVF we can get that v square by u square, that is m square. M square means if in case of positive sign, according to the sign convention, the positive sign can be taken, the m value is taken for the positive sign taken as that the image and object both are moving in the same direction, means both are image along the same direction, means along the same direction. The both in case of positive ml indicates that objective and image are along the same direction, means here is the about the magnification. Once again, magnification means the ratio of the size of the image to the size of the object is called magnification. That is m is equal to, that is denoted by m. Then the m value depends on the position of the object placed in the principal axis, means position of the object. Then in the case of magnification are two types, that is lateral magnification and linear magnification or longitudinal magnification. Here lateral magnification means when the object is placed perpendicular, means perpendicular to the principal axis, then that magnification then the image is also formed as the magnification same as perpendicularly. So that's why m is equal to, and once again is the definition of magnification according to this one, then whenever the object is perpendicular, the ratio of the height of the image to the height of the object, that is m is equal to h dash by h. Here is the ray diagram which we draw. Then whenever we are taking the according to the sign convention, if we mention the values of sign convention, and then we can get that m is equal to v by u is equal to f by u minus f be the value for magnification in terms of positive taken. M value can be positive taken whenever it is a erect image, means whenever above the principal axis if the image is formed, that should be taken, m value can be positive. Either if in case of inverted image, it means below the axis, below the principal axis, m value should taken as negative. And next one is a longitudinal magnification. When the object is placed parallel, when the object is placed parallel to the principal axis, then image is also formed parallelly. And for a short image we can say that the delta u can be taken as the length of the object and delta v be the length of the image. Then from that we can get that linear magnification ml is equal to delta v by delta u, means here the ratio of the length of the image to the length of the object, that is v square by u square, that is the value is equal to m square value. Then positive can be considered as a positive can be denotes that the m value means the object and image is along the same direction, This is about magnification. Next we are going to know that what is the power of a lens. So power of a lens means here the what is meant by the power of a lens. We know that when if we take the convex lens, means the converging lens, the light ray is whenever incident on the convex lens, they move towards the principal axis. And if in case of the concave lens, when the light ray incident on the concave lens, it's a diverging lens, so light diverged means moves away from the principal axis. According to this, the power of a lens is also can be considered as the power of a convex lens also, because of the light, whenever the light is incident on that, the ability of the lens, when the light is incident on the lens, the ability of lens which bends towards the principal axis is called power of a lens. Means here when the light ray is incident on when the light ray is passing an incident on some of the principal axis, some of the point, then whenever the light ray is incident on means it is a principal axis, whenever it is bends towards the principal axis, the ability of that lens is called as a power of a lens. Means here that the ability of a lens to bend the light ray towards the principal axis is called as a power of a lens. Also we can say that simply we can say that the reciprocal of focal length. If the power is more, the focal length will be less, because of, if in case we know that whenever the instant on the principal focus, whenever the light is instant on the principal axis, that will be the principal focus, then the distance is called as focus f. If the lens is having more ability, then it will bend near the center, then their focal length will be less. Like that. So that's why we can say that is reciprocal of focal length is called as a power, means P. The reciprocal of focal length is called a power of a lens. The power of a lens can be considered, power P is equal to 1 by focal length, that is F is 1 by F. Then P is equal to 1 by F be the formula of power of a lens. Then here the unit of power is diopter. The unit of power is diopter. In case of lens, we will denote that diopters is the measure of lens power. Diopter is the measure of lens power, where the focal length is in meters. Also diopter, or we can write that diopter or per meter also we can write that. Means 1 diopter is equal to 1 per meter, we can write that. 1 per meter we can write that, because of here the F is in a centimeters or meters. Whenever it is in meters, then 1 diopter is equal to 1 per meter, we can write that. It means say whenever the F is in meters, then the power of a lens is a diopter. The power of a lens is a diopter. So here it is that the value of power can be taken positive for convex lens, because of they converged, means moving towards the they can be converged. So that's why the convex lens can be converged. So that's why they move the light ray towards the principal axis. Convex lenses moves towards the principal axis. So that's why we can take that power of a convex lens is positive for convex lenses, and when according to the negative, because of the light rays, the concave lenses is the diverging lens, means the light ray is moving, refract away from the principal axis. So that's why we can consider that concave lenses are taken as a negative value for power. Means power of a lens means the ability of the lens to bend the light ray towards the principal axis is called power of a lens, or the reciprocal of focal length. The reciprocal of focal length is called also power of a lens. Power P is equal to 1 by focal length, that is equal to 1 by F. Then power P is equal to 1 by F, means whenever it is F is in meters, then power of a lens units are diopter or per meter, we can say. Then the power of a convex lens, means the value of power for the convex lens can be taken positive, because of convex lenses can be called as a converging lens. So that's why the light ray can be converged towards the principal axis by the convex lenses. So that's why that can be taken as a positive. Concave lens can be called as a diverging. Diverging means the light ray is moving away from the principal axis because of concave lens. Concave lenses are diverging, so that's why light ray is moving away from the principal axis. So that's why here the power of a concave lenses can be taken as a negative. This is about power of a convex lens or concave lenses.